All right, so we can. Okay. Okay, it sounds good. All right. Okay, it took longer than expected. Sorry, guys. All right, so we'll resume with the where we left with the lab, and then we'll go on with the class. Hopefully, we can finish this quickly. So, yeah, we'll make announcements towards the end regarding the quiz and so on. Okay. So I did a few updates on the slides. You should be able to access the website now. Again, I think that the password is in Slack or Blackboard. Yeah, password and username. Yeah, I did update a few things I just want to point out to you. So the GitHub desktop for using that's wrong. She's the VS Code. Sorry, I did the update, but I didn't do it right. So the preferred version, the preferred method for committing your homework is going to be the git clone command through VS Code, so that you don't need to install anything else, and you just do it from the IDE. It's easier. For the command line, you need to go to this link on GitHub, and it explains how you can create a token, because now, starting I think August 15th, they disable just the straight SSH access with password. So now you need to create a token where you say for what you're using it, and then the command line will work as well. Okay. Yeah, so here I put a disclaimer. So if you are using the command line in VS Code or just on a terminal, make sure not to copy the things that start with pound here, because they're comments, and then the commands are going to get confused. That happened to me last time. The other addition is here about how you set up Visual Studio Code to debug, and I'll show you that right now. So, whoops. Okay. Cancel. This one, we don't need it. All right, so this is the repository that I cloned last time. So we're going to restart there. Code -n. And I think we were looking at the assignment, the exercise. No, not the exercise, the simple.exe. Okay, so yeah, before we get there, maybe we'll run a few commands with it. So here it's simple. Whoops. Okay, it doesn't work because you need to prefix with a dot. And you actually need to, oh, I'm not at the right place, sorry. cd lab simple.exe. Okay, those slash simple.exe. Okay, no, nothing happens. We use commander in there, so this is the standard that comes standard with commander that you get the printout for the help. And what does it want? It wants a CSV file to convert. And there are no options because this is just an example, a simple one. So I'm going to call it, and I think here we have an example CSV file. Oops. And I don't know if it works or not, but it doesn't look like. So they say that it's broken, so you need to debug this. So how do you do? This is the standard method that works with all JavaScript. You basically go in the file where you want to debug, and you put some console log statements. So here we have some. So apparently we're not getting there. It's weird because I don't see this point either. So we're going to go in here and just put our console log. So the console log function is used in this way. You can basically put a string in there. So in JavaScript, the single quotes, double quotes are the same. You can concatenate strings with the comma, or in that case, there are no white spaces that are in between the strings. Or you can use a plus, and then you want to put some spaces in between the text. Otherwise, everything is going to come out jumbled up. Now these variables here don't exist, so I'm going to remove them and maybe just put something like hello. Okay. Okay, so we see that this prints out. So that obviously you can you can use wherever you like. If you're inside functions such as here we have an error handler, then you can go and put some statement in there, and they get executed whenever this statement is executed. So initially, the parser is going to start loading the file, and yeah, everything runs synchronously, aside from functions that might be asynchronous. But I'll tell you that later on, when we look at the promises and the other things that are specific to working in the browser. Here we're just trying to understand how do you debug it. Now there is a debugger that comes with the Visual Studio Code, and to set it up, It's quite simple. You just go here. This is the run and debug button. And you can see that it gives you some choices. So you can try to do this, run and debug, and then it's going to stop the debugger based on the file that you've opened. And that works most of the time. However, for command line tools, that's kind of impractical because you want to pass arguments. Such as here, we call it enable series. So in order to do that, you need to do the other choice that they say is to create a launch to JSON file. So I click the link, and there you have a bunch of choices. Because it's a node application, we would select the node.js. If it would be a web page, then we would select the Chrome. Okay. And that's, as you can see, what is this? You recognize it? We discussed it. I mean, I'm talking about the file type. It's a JSON file, right? So this is JSON, so it's given pairs objects that are nested together. You get some arrays also in there, and everything is strings aside from numbers that can be put as numbers there only in the values, not in the keys. So this one. You can see here it links to the executable, but if you want to pass some parameters, then this is what I've put in the slides here. So here you would basically add another line like this. Now you can see that this here we're inside an object, and so the key value pairs are separated with a comma. So if you want to add something, then you need to be, you see that you get an error here. And that is because we need to add the comma there. And then you can just launch it. So here we can put the file name that is faithful.csv. Yeah, actually, let me run the help so you see how the help works. So yeah, the help. So supposing that help as a parameter, which it doesn't, then the value you would add here. Okay, but it doesn't. So I'm going to remove it. And this is it. So you can start it by clicking the green button here. Okay, so somebody else should mute himself because I hear talking in the Zoom. Thank you. Okay, this one we don't need. Okay, so it did run and then nothing happened because we didn't put a breakpoint. So we need to go and put a breakpoint somewhere, such as here, which you do in this way. And there we go. So as you can see, it goes in there, and then you can use the mouse to mouse over variables and print out values in the console down here. So here, for instance, we have this variable that is programmed. If I want to print it out, you see that it's available in the scope, and then you can go and look at the different. Okay, I'd like to know who is talking here in the Zoom. Please mute yourself. Yeah. So just here I'm just giving you the mechanics on how to debug it. I'm not going to do the actual debugging. That will do it little by little with the homeworks if needed. So usually you good enough to do most of the work with the console log. but sometimes things become intricated, and you want to resort to the debugger. So this is the way to do it. Okay, so if there are no questions on that, I'll move on to the following example, that is how do you deal with an HTML page that has some JavaScript on it. No questions? Okay, fantastic. Okay, so there the HTML is going to be interpreted by the browser. So what you want to use is the debugger that comes standard with the browser. So in Chrome, it's called DevTools. How do you call it? Simply by, so you have the keyboard shortcuts down there, so you need to learn them. Here you go. I'm doing it on these pages that have presentation that happen to be a web page. And so you can see basically the console on here. That's mostly where you're going to look. First, if there are any errors in the page, they will show up there. You will most likely only see in-ear errors that have to do with JavaScript that is running the page, but they won't tell you if you make errors in the JavaScript, in the HTML itself, and that is because the kind of user experience features that all the browser comes standard with is that they don't want, if there is something that doesn't work, they don't want to bother the user because the user has no idea how to work. The page is supposed to show. So when you debug the visuals, you really need to go and look at your page, and the IDEs usually have some features. So I think this is the page. So say if I want to, if I make a mistake like this, you see that nothing bad is going to happen here, right? So we can go to the first page, and there, I think I changed the group paragraph is in front of my name, but it's right after another paragraph, so the browser is trying to fix it, and here it did a good job. So most of the time, if you have syntax errors, you will only see them in here, and yeah. Here you see that it's highlighted in red, so you can see that there is an error, and you can go and fix it. But otherwise, debugging the HTML part is always a little bit tricky. So the best thing to do is to use the editor that, as you just saw, has features so that if you call a tag, then it basically does the authentication and creates the closing part of the tag. So you minimize when you write HTML code, the errors that are created in there. Now, if something that doesn't show up correctly and you want to try to see a little bit how it is interpreted in the browser, then you can go and use this button here, the select element, and you just mouse over different parts. And then when you click it, it's going to tell you where it is in the page. And you can even go and change the properties from there. So I don't know, yeah. If you want to make it, yeah. So the default is absolute, that's why it moved in the middle. Yeah, which is equivalent to unset. So that's basically how you would go and fix problems that you have in the HTML. You can also edit in here, actually. Yeah, I'm going to put I don't know, 20 pixels. That doesn't do anything, but yeah, did it do something? Maybe, maybe. Yeah, I think this one, we should be able to see it. If we put 20 pixel here, the logo, so that you get much more. Yeah. So again, the button, the select button here, and then you just mouse over on the content and you get it to work. Now, this is only for the part that has to do with the HTML. If you want to debug, let me rewrite this before. Okay. This is good. If you want to actually debug the JavaScript that is running in the page, then the best option is to use the debugger also in the Chrome. You can also map it to Visual Studio Code, but it's more complicated to do. And most of the time, I think you're good enough with just what is in the page. So I'm going to move to there. Yeah, stop the debugger here on this one. So you can create also multiple, if you have like here, multiple folders that you want to work on, you can create multiple consoles. So here we go. So we're going to go in lab. Simple HTML. Okay, so this one is just a stub that I created. Normally you have a README file that tells you what you need to do and what it is. I didn't create it here because it's just a simple page that we can take a look at. Here it is. That has not much in it. But you see that there is a package to JSON. Well, this is the wrong one. Sorry. I'm sorry. The Zoom window is all the time in the way. This is the one that I have outside that is not useful. We want to open this one. Yeah. So here you see that we're using some libraries, and obviously these should be referenced in the package to JSON. You see here that it depends on D3. So now you know that you need to run npm install, and it creates the node.json module, that is going to have a bunch of things in there. You see that we have the commander because I don't know why, but there is also the D3 that is here. And maybe that the commander is also a dependency of D3. So what we get is D3 plus all these dependencies. If we look into this, you'll see that there are here some. This is the main library file, and then it's split in different pieces. So we'll look at this later on. But what I want to point out is that there is d3.read.js. So this is a minified version of this one that is just the file that is meant for editing. And the minified version looks like this. So we'll take a look at this later on, but basically, because this file normally gets shipped to the network, you want to have it as small as possible. So people don't have to wait for the page to load. So you see that everything is replaced with one-letter words, and it's all jumbled up. The spaces are removed. So the browser can make sense of this. We cannot. But this is usually what you want to use when you're publishing your content. The other one is really just for debugging. And so when you go in the index, not this one, the other one. I don't know why you closed it. Index, yeah. Yeah, you see that we load the minified version. Yeah. So if you want, you can also just load the regular version. But obviously it's going to be slower. Okay. So here we get this page, and okay, obviously the first thing to do is to get it to run. Now you see that I don't know if this probably is not going to work if we just go here. Let me open up. Okay, now if I double click this, it works. Okay. Yeah, we're using the file. So here you see normally you get the HTTPS, and so you're using for HTTP. So you're using the HTTP protocol to go and get the data for the page. But here we're just asking the browser to load it. Here the protocol is file. It's a file protocol. Here. So it's just loading from the local drive. And in this particular case, it works. But if you're actually loading data, here the data are in the page, but if you're loading data as a separate file in the drive, it will not. Okay, so here is the debugger. So to debug, same thing as we did before. You just go in there, you put a breakpoint, you reload this, and then you're good to go. Okay. Now, as I said, you can also hook it up and do the debugging part in Visual Studio Code. I'm not going to show it because this is good enough for the moment. The additional thing that you need to do then in Visual Studio Code is similar to what we did before. You need to start the debugger in Visual Studio Code to hook to an instance of Chrome. And that's basically the same process that we did before with the console, except that you don't choose Node.js, but you choose Chrome. And it will spawn a window with Chrome. Yeah, but other than that, really, there are not many advantages other than, because you always need two windows. Today, the browser window and then the IDE window. Usually people put those one next to the other. So yeah. I guess that the only disadvantage is that debugging in the same code, then you can just go in and write your code as you debug. And if you do it with a browser sync, then it becomes interactive. And I think that's what you basically did with the homework. Is when you install you do the npm install at the top level for the homework is going to, and you do the npm run serve. I think it's starting. Let me see this. It's starting. Yeah, it's starting browser sync, so you get what is called hot reload, which means that every time you change the code, the page is going to refresh. Yeah, so hopefully you did that for the homework. So I won't go through it unless there are questions. Yeah. Okay, so this was for the HTML. Okay, the view, I'm going just to show you a little bit what it is, so you're not, for those who are not familiar with frameworks, you know what it is, and you know also how to debug it. But we'll come back to that later on. And if you don't have, so for the project, yeah, long story short, it's feasible to build a website with vanilla JavaScript, just writing JavaScript. However, it's super complicated to do. And that's what these frameworks are basically providing, is that they give you all the tools that you need to do tabs with where you click on a tab, you go to a different page, and do all the mechanics that are needed when you build a complex web app. So for the project, I'm going to ask that you use one of those because it's much simpler for you, and you can concentrate on building the visualization. And I'm not going to enforce any particular framework. So I know that some people are familiar with React. If that's what you want to use that, that's fine with me. But I understand that a lot of people that don't have any experience with the frameworks are going to be taken back by using React or Angular. So I'm going to give you examples on how to put visualization, control visualization to interaction, mainly with Vue. So that's, and so if you're not familiar with any other framework, that would be a good choice to use for the project. Okay, so yeah, so this is a good example. So this is created. I think I put the instruction to create it. If you want, you can just go and refer to that to create it from scratch. But this is just the output of what you get when you use the Vue CLI to generate the stuff for a web app. And so, as you can see, it creates everything that you really need. It initializes Git, the file that you should not worry about, and it creates everything that is kind of standard that tells you a little bit what it is. But by now, you know how these things work. So you see that you need to run the npm install if you want to do the setup. And then the npm run serve command. And again, the serve is down here. And if you look at it here, you see that what they're doing is that they have this command line interface service that is going to create a server that is going to show your page, your web app. Okay. So I'm going just to do that. npm install. Okay. Yeah, don't ask me why do we get all this warning, because I think I created this 2 weeks ago, but yeah, they keep upgrading these packages all the time. So in this case, there is not much that to worry about, again, because these are security notices, as I explained last time. So you can try to fix them if you want, but this is just running on your local system. So there is no risk that you compromise your system. npm run serve. Okay, again, you see that it is doing what I was showing before, that it's calling the UCLI to serve the pages. And what it's doing here is basically compiling the code into JavaScript so that it becomes visible. Now, these frameworks, they all do the same thing. You don't, they provide you some scaffolding code where you go and write your code in, but they don't do it in plain JavaScript. They tend to extend the code to HTML. And the code, the JavaScript code turns the page with new tags and ways for you to interact with the page from the code. But this is not done purely in HTML. The HTML is extended, it's not standard. So everything needs to be brought down back to plain HTML and JavaScript to be able to run it in the browser. And I'll show you maybe one of the view files in a minute, so you understand a little bit why this is. Let's go first and see the website. So you there you just click on the link. You need to press with the Windows key or the Apple key on Mac, and then you see the website here working. So this is what you get by default. Now, if we go and look at this, here you have the sources, and you see that this is basically our app here. It's actually changed by the browser because I've put a debugging. Debug it. But normally this is just a minified version as well, and so that's not very useful for debugging. Now the process of generating the HTML and JavaScript is done by a different tool. So in this case, they're using the thing that's called Webpack. And because I've set up the project so that you can debug it, then what Webpack does is that it shows you the original symbol from the project. So you see that the app is here. That is basically the same. And in here and these are the same that what we have in the project. And you see that they're in this form here where it's 3 parts right here. So you have an HTML that is extended. You see the things that are not standard HTML. That's what's going on. All right. Are there any other things that are non-standard? All this is just standard HTML. And then you have see the first part is wrapped into this template tag. So this is called the view as a view on a database. And that basically is the HTML code that relates to what you're going to see in the page. And then there are 2 other sections. The one that is here with script is what is called the controller. And what it does is that it allows you to write HTML code that is going to be able to change things in the page. That's where you write your interactive. Eventually, this code plus the template are going to be changed into just an HTML file where the JavaScript is pasted here and it's going to, yeah. So that's basically the last section here is also something that has to do with the page. So this is the CSS that comes with it. But it's not related to the model view controller. So all of these frameworks, they work with this architecture where you try to separate the model that is your data from the view that is what you're going to have in the page, and the controller that is what links the data with the view. All right. So this said, now you know how you can debug this, and that is basically to just go in here and you can put the breakpoint. So here we just have one component meaning that is subpart of the page. A page might have multiple components. The idea is that you can reuse this component. But the output view here is just one. That's the main entry point, but we could have also other pages that would be similar to that. Yeah. So it's in Webpack. Because Webpack is the machinery that this is where is it? Sorry. Up. Okay. This is the lab, yeah. Let me just go by here and get the page. Here. Oh, the view page. So the view page, the only thing I did is go here and then click this link. Yeah. Well, you can cut and paste it in the browser if you run this in the terminal. You can do the same, but here it's hyperlinked and you can access it directly. All right. So I think for this one, I'll stop here just to give you a sense, and so that you see that very quickly you get something that is a web page for free, and it's fairly straightforward to extend it. Yep. Can which file? This file. Hello world.view. You mean in the sources? So these are the files that are the same that we have on here, right? Yeah. It's exactly the same layout. Yeah. So it's already set up so that Webpack recreates the hierarchy and you can debug it, right? So you can also do the same thing that we did with the Node app, that is to debug it inside the code. And I think I don't know if I put the link, but yeah, same pro and cons. I think that there are more cons with the view app because it's kind of heavier machinery to get going. And so I think it's, for me at least, it's faster to just go in the browser and inspecting there whenever you really have some trouble with the code and to try to launch it to the code and so on. But if you want to do that, there is an explanation in the Vue website on how to link it, and basically you need to just set up a launch the JSON that does the right thing for you. Okay, so no more question about this. So this is just a preview, and you don't have to do anything, right? For the but I want to, as I said, I want to try to do a little bit of top to bottom, as opposed to start from how do you write JavaScript and eventually get to this. So at least you know where it's going. And it's also nice because you're getting to get familiar with all these files, all different files, and the file format, how you do things is similar across the different examples that we gave. Okay. The exercise is the 1 and 2. I can give you an example. I think I had it in there, but and it's basically the same thing that you need to do for the homework, right? Okay. So here they are. Yeah, I think this I got from last year. So but the yeah, I want just to stress the point that the reason we're doing this is not too much for you to play around with it, but try to understand a little bit what is it that is needed in terms of creating a visualization. So here we're learning obviously to use this charting that we do achieve, and now you know the homework that these charts are created by a JavaScript library that is the Google chart. And the process is basically the same all the time, is that you need to format the data first so that the charting software is going to be up with what you feed it. And so you really want to be careful, not just to go and get the data and slap it into an Excel and try to plot it, because then it's complicated. You need to select things that you want and not select things that you don't want. For instance, these might get used for the labels for the axis. So I'd rather just put here what I want for the axis than to go and do extra work after. Here in particular, you do it in the spreadsheet to start with, then you're going to get the right tables of the map, right? Then I would not bother with the data that I'm not interested in. So here you see that I'm just using the same countries, whatever I want to track. And then I'm basically just one step away from creating the chart. And most of which is straightforward, right? You just select everything, including the columns, and then you're done. Now this format here is not the usual format that you might want to have in a data frame, right? If you load this into Python, pandas, you want to have one record per line. So maybe this date, we need to encode it as one column, right? And then we have multiple rows for each one of these. So the way they've stored it here is just a series here is based on a long format that is not useful. But this is what people understand, and that's why they use that choice in the Google Sheet. Because for people, it's easier to work with. For you that do data science, this is more complicated, right? So in Python, that tells you that that's why you have all these libraries that work off the data frame to do plots, because they're already formatted in the right way. So all you need to do is put the right data in, and you're going to get the plot out. Yeah. So most of the information is in the data, but not everything. So here, for instance, you see that I have to go and change the title, and then I have to go and change this. And then there is another mapping here that might be obvious, is that I need to go and format these labels because the default I didn't type, and I change the scale for the axis. Right, so I put a log scale here because I want to see this a little bit better for the smaller value, because otherwise everything is jumbled up at the bottom. Yeah. So all those are choices that you make as a designer, and that depends on what you want to show to people, right? Because this is the information. The information here is somebody who looks at be able to interpret to read the stuff, and that's why there is all this information. Yeah. So somebody was showing the last week one of the slots, and then here the days. The dates were not shown, and that's because I think the row here was not selected, and I don't think I did anything spatial. Maybe I have to set the time to be a date. But basically, the choice is that this axis is an axis of time, and so the software for to create an axis of time needs to know that these data points are to do with time, right? And so the other possibility is to just rely on text. That might be what is working. This way. So if you have categorical variables, the question is text, and that would work. I don't know in this particular case. This format, but definitely if you want the dates to be shown in a different way, then you plot what's there, then you need to tell it that it's a time, and then you can change the setting. And this one, obviously, this information is not present there. From the table, we don't know what it is. So I have to go in and do it. Okay, the pie chart is very similar, and so here you see that also they're kind of cutting corners to make it easier for people, because this one I did with the first two columns here. So this I got with a pivot table. Everybody is good with that? Yes? Yes, no? Yes, okay. So when you create your pivot table, you decide what the rows and columns are. Then it's going to be aggregates here, which is fine. But here what we want to do is a pie chart, and the pie chart is about proportion, right? So ideally, what you want to give it are percentages. And what I did here is I just marking the number. But you see that you can do it. You can do the plot both with A and B and with A and C, and you get the same thing. And that is because the pie chart software automatically computes the percentage. Yep. Yes. So that's from the code, right?
Yes. And then there are the numbers that I included, so I thought we had to for our.
Yeah, that's fine to hard code it. Yeah. No, I think you should. The point there is that you do it by code. Yeah. And so you're exactly right. I don't know if I have it somewhere, but the where is it? Where is it? Maybe I can try to open a quick window and then Google charts 9 chart. No, pie chart. Okay. Yeah. So here you have the code. So you see that they're basically doing what is done in the page. And my guess is that, yeah, so you see it's exactly the same thing. They're not putting percentages here, they're just putting some numbers. And then it's going to compute it. If you put the percentage, it's just going to go right. Yeah. So, data-wise, you see that this is an array of arrays. And then the first row is going to be used for the title. So on. That corresponds for which row in the spreadsheet. And here we get the pie label and pie button. So here they decide to do it as a table for the Google Sheet. Otherwise, you could get focus into options. And that's what other libraries are doing. Okay. Now the other thing that you see is here. So what category would you say is Google chart? Remember the slide with the different categories that I had for this one. I'm going to fill it. I think it was here. I already did for you. The Google chart is the chart typology is you saw in the code. Where is the code? You saw in the code that here we have a name chart. We want a type. This is a type of chart. It's part of the chart. Yeah. Okay. So I think we can do a break and then we'll go on with the class content that is not too long today. So, yep. Thank you. Thank you. Okay, now it should be good. Okay. So let's go through this. So we're going to talk a little bit about data and how they relate to visualization, but mostly things that I already mentioned last time. So data is plural, datum is singular, and you'll see that in the three, when they refer to a single piece of data, they call it datum. So that's something that you want to keep in mind. So when you build a chart, it depends the form that you're going to use. It really depends on the data. So a scatter plot, you need continuous data. So there are two types. Bar chart, and maybe categories with some values that are attached to it, right? So yeah, so it's important to understand a little bit how the type of the data and the operations that you can do on it relate to the things that you can visually do with charts. And that basically tells you what information you should put in a chart, given the type of data that you have. So for here, we're going just to go through the different categories of data. So for categorical data that are nominal, it means that they're just strings, names. So in general, there is no specific way to order them. So the only thing that you can do is basically tell them apart. And you see there an example of categorical nominal data. In some cases, there is some type of ordering that is useful to attach to categorical data. So you might have seen at the airport now that it's popular. You have this displays where you can, with smiley faces, that ask you what they're doing. In that case, there is another order for those little presentation of patterns, right? Levels of difficulty also obviously is another good example. In that case, you can order the data. So that means that in your bar chart, it does make a sense to put some type of ordering. And here we're talking just about the axis where the labels lie. But obviously, these categorical data you can link to a bar chart with numerical data. So there is another type of ordering that comes from the numerical data, right? Where you can order your bar chart so that the biggest bar is on the left side and the smallest one is on the right side. And in that case, you basically make it easier and faster for people to access the information order. People also use this adjectives here for the categorical data, like binomial, dichotomous, or non-dichotomous. So these are kind of spatial cases where you have only a couple of nominal values, and you see their data. Yeah, so the non-dichotomous, the example is the Likert scale. That's a scale that you see in surveys. If you're familiar with those, where they say how much do you agree or disagree, and they're usually a scale of 5 or 10. For those, so that's non-dichotomous because you have more than 2 values. The numerical data, you have essentially 2 here that are ratio and interval. So you want to know the difference between the two. So the ratio, the ordering is is meaningful, as well as the differences, and doubling is meaningful, and that is because there is a fixed value for the zero. So something that is twice does is actually 2 times the value. And an example is the Kelvin scale that starts at 0. So 2 times 20 degrees Kelvin is twice as hot as 10 degrees Kelvin times 2. The interval is basically the same, but the 0 doesn't have a meaning, and so doubling is not something that is useful to compare. So if you want to show Kelvin with bar charts, obviously you need to keep in mind that it's fine if you got 0 value, because well, it's actually not fine, because the information that you want to portray is that something is twice as hot. If you don't include the 0, then people will not be able to relate to it. But if you look at degrees in Celsius, then you cannot do the same logic, meaning that 40 degrees Celsius is not twice 20 degrees Celsius as hot. And you have some other examples there. Yeah, example of quiz. So somebody was asking about the quiz. I'm going to open the first one after the lecture. Today I'll leave it open till Wednesday before class. So you can take it at any time. This is the format. And this is a question for next week. Another question so that you can practice. And another question. And even another one. So this is the Likert scale. So you can see what it looks like. Okay, so moving up with the data and how people think about data. So there is usually this idea of creating a model of how you model really the way you think about data. And you have 3 main classes of models that people use. The first one is the conceptual model. Second one is the logical model, and the last one is a physical model. Depending on what they include. So the semantic description is part of the conceptual model. The logical and physical have details about the logical implementation whatever data you're discussing, and physical has to do with the physical implementation. So if you're talking about servers and how you deploy them, the logical view might be how they're connected, and that can be shown with some diagram. The physical, you can also show it with diagram, maybe on a map, where your servers are located. So here is an example of a logical data model. So this is for I don't know what is the example here. So I think that these are just characters in a movie. And you see that you represent the different entities with different graphical presentations, or your boxes, their ovals, and so on, and the connections between the entities allow them to have some the connection between the data. And so in each symbol box or the here. As you see that they have some added information there that is added so that you can understand better what the relationship entails. Another example here is at a database level. So this is SQL, MySQL actually. Software that shows a conceptual model at the top, where we are only talking about these two databases, the user identification. The logical model adds detail, where you can see the relationship between the tables and what are the data fields. And then the physical explains what is the type of the different data that is in the database. So that's basically it for the data. In terms of visualization, people also think of visualization with a kind of a mental model, if you want. And so this is one of the early work on this area, where the author here put together a diagram that explains how you build visualization and how we interact with it. And so if you think about the homework, you can make sense now of the different steps. So the raw data is basically what you get from the source where the data is acquired. And the first thing that needs to happen is that you need to transform it into some tabular form that is adapted to the tools that you use. The following step, and this I think we have a good example. Right? The following step is to create mappings between the data and visual structure. That means that's something that people refer to as marks usually in graphics. So do you get a data point to a circle, or do you get it to a bar form to create either a scatter plot or a bar chart? With what is here understood as visual mappings. And then you want to do a view transformation. So what does it mean? Well, if you have data that you have to do with lengths or distances, and there are thousands of kilometers, then you cannot go with a scale of 1, depending on the size of the graphic that you can create in the display. And so you need to transform the data so that they are actually they're going to map to the display, to the size of the display. Another example of view transformation is what we saw a moment ago, where we're changing a linear axis to a local scale. Yeah. And then so this is both the creator of the graphic and the person who is going to look at it. And so you can lay at each one of these stages with changes that are going to affect how the view is going to appear. But you can also in some instances with interactive charts, go and interact with the chart itself. And so one example is what you see with the interactive version of the Google chart, where you can mouse over and you can access the data at the top. Or you could have even buttons that go different data sets and so on. So you can so that's all the interactivity there is usually used to allow to support exploration. Okay, so the second part is visualization techniques, and I'm going really to go quick about it, so we can get back to to the web technologies and already finish up on that. I'm going mainly to discuss a little bit some examples of these. So you have different ways to categorize the visual forms that you can create in visualization. So this is one that it is practical enough to use. So charts, these are most of the charts that you're familiar with. The graphs and trees are things that are built with data that is hierarchical. Clouds is also about hierarchical data, temporal data, time series typically, and then everything that has to do with maps. Those are the 5 big categories of graphical forms that you can create. So the point here is that you start talking about these different forms and have them know what is available so that you can use them according to the information that you want to put forward in your graphics. So I'm passing on those. Just pay attention to probably the names that you don't know. So this is typically called a lollipop chart. So people use a bit of a different name for that. And in here, for instance, why would you choose this one? Well, you see that this is kind of skinnier representation than this, you need less space. So if space is a problem, then that is probably something that is useful to you. Here, all of these, I think that yeah, they're not that much used. So this one is a historical chart from 1980. It's called the Coxcomb chart. And basically, it's a start bar chart in a radial layout. So it was good at the time. It came up and kind of novel, but especially that came out very early on in terms of chart development history. However, you see that it's kind of difficult to read. And the reason is that we're not very good at comparing areas on graphics. And so this is much better done with just bar charts, but not a radial layout. The Merrimaker chart here is a little bit more complicated because so you basically have stack bar charts that are maxed out at 100% here. So it's a percentage. So it's a kind of area representation. And the different categories, and you see that the bars also are not all of the same size. So it's not really a bar chart. Closer to a map. So you have percentages, categories, and here you have some additional numbers that give you for the total amounts here that are these are sales I think the US and the international. That allows you to read this. What is the dollar amount that is related to this? At the same time that you can judge it visually based on the size. So those that they're not very familiar, but people use them in a financial context. Similar to the waterfall chart that shows increases and decreases that are corresponded. So you can see very quickly when there is an increase or a decrease. Yeah, donut chart, I guess, it's just a pie chart where you take out the middle, and you see that in Google Charts they also have this available. I don't remember if it's part of the pie chart or if it's another parameter of the pie chart, but it's just a separate flow. Spark line similar to the lollipop chart. So when you don't have space, you can do a little line. You can make them interactive, and so on. Slope graph parallel coordinates. So this one is good for, I'm going to get back to it. It is good for showing changes here for different categories. And comparing the changes. Because you can see that here very quickly, we can see which one are increasing, which one are decreasing. So the parallel coordinate is unlike this one because the axes here are different shapes. And this allows you basically to look at multimodal data. Radar chart, I think that you're familiar with those. And the area chart. Yeah, by the way, this is also yeah, something like this. So here are physically two plots. And so this is also an area chart. Stream graph. So the stream graph is basically the same thing as this, but you see that this distorted based on some heuristic. So people use this for songs. Yeah, because it's attractive and it looks good, but it's hard to read. In terms of grafton trees, so the basic tree structure is called the pentagram. So these are usually used in science paper. The genes and these kind of things, you can get something like this. Hierarchical, then this is the standard implementation. A lot of time, if you want to show the tree as a nicer with a nicer layout, then what you do is that you use any of the available layouts. So and this comes as algorithm. We're going to see how to create this thing later on, but this one is the rainbow support tree. So you see that the leaves are all placed on a circle. The outermost ones, and then you have one the root of the tree that is right at the middle, and labels here that are across the radius. So those you can also make interactive, but yeah, if people use them because they're nice, they look nice. Tree map, different from the Merrimaker chart. It's just an arrangement, again, 100%, right? And the area is proportional to the pie, similar to the pie chart, except that the pie puts it in a radial layout with the percentage. Here you use an area. And there is an algorithm to create this mapping. That's obviously not obvious. Easy to do. It looks nice and are on it. Now this is hierarchical. That's the other thing that you want to tree map is hierarchical. So here the colors are the top level of the hierarchy, but you see that here you have subdivisions inside for the nodes that are lower. Sunburst, basically the same thing, but another fancy layout where you have the root node in the middle. The areas that are pie-like that come out to the side. sunburst. Alluvial diagram. So here is to compare different categories for different variables. So here we have, so this one is is an example for the Titanic perished depending on class 6 age and who survived it. And here you see these ribbons here, they basically relate the proportion of one category to the following category and so on. So they basically cut across. Yeah. So again, not used a lot, but it looks nice and it's getting more popular now. Sankey diagram is a kind of flow chart, as is this one. And this one was developed for purposes of showing flow in steam machinery, but now it's also used here to relate multiple data. So here you see the proportion of different energy types, how they relate to how they're generated and how they're used. So here, for instance, this is the electricity that goes to the grid, so you can see it's coming from thermal and it's gas and heated. So it's similar to here, you can see the proportion in the flow. So some of these they're directed, and this one is not. When you're working on, when this was originally developed, you had a flow, physical flow, and the idea was that to show that, so the ribbons would did an arrow to show the direction in which the flow is flowing. In this particular case, you can just reverse it. So they didn't bother putting that information in. Graphs and trees, another one. So this is called a network graph. So the social media type of data is used quite a bit. And we'll see that D3 has a layout that is called the force layout, where you can actually take one of the nodes and drag it around. And that allows you to explore better the layout by singling out one of the nodes and seeing which one are connected. And they're basically the movement and interaction allows you to operate that. It map. So you're familiar probably with the it map on the map, but it's also just a table of values into D that is colored. And here we have, so the color are just random, they're based on the value. So there is a color scale that shows that. We're going to talk about the color scale later on. Another way to look at the relationship. So here it's basically two variable, right? It's a matrix. So here is the core diagram that will also show the relationship between different categories with robots. And again, it doesn't look like it, but the data are also in the form of 2D table. The clouds essentially showing either hierarchy and or proximity. So it's used a lot with words. So the example of the word cloud and bubble cloud there with words. Depending on if you just put text or if you size. So here we're sizing the text to some value. So these are probably the words that are workout, you basically take a piece of text and count how much one word is important to the document, and that gives you a ranking and the value you encode in the side of the text. And the way you put this thing together here, you see that it lose shape. So obviously you do this algorithmically because it's impractical to do it manually. It's similar for the bubble clouds. The bubble equals a value, and the razor is sized in accordance. The circle packing is just a type of bubble cloud where you have this particular layout that shows the hierarchy, and each one of these are a bubble cloud. So yeah, if you have continents, then there would be a bubble, and then the inside the other bubbles for the countries. Then you get the cities, then you have another bubble inside. Okay, so that type of hierarchy. Temporal, not much to say. The timelines and obviously the line chart to show the time series, and then the maps. So the maps you have what are called thematic maps, that are maps with a theme. So examples here are the place map that you have seen probably in elections. Proportional symbol is that you just take a symbol and you replicate it with sizing it to some value. So here it's bubbles, and it's choice because it's symmetric, but you can also put bars there if you like. The dot map is historically one of the first ones that of these thematic maps was developed. And basically, what you do is that to each point you add one instance of a phenomenon or multiple. So this could count. This could count just households, or it could encode multiple people living at one place with one dot. Yeah, the cartogram is basically a map that is distorted, and these are the weather maps where you have different that are usually with contours that show pressure, temperature, and so on. And their technical name is in isoplate. And then the other category is the non-thematic maps. And I'll finish with this. You have here are some examples of maps that are called based on what they're good at. So this one is a topographic map that shows the topography of an ant. People who go about with balls, they need the specific information. So those are the nautical maps. And then you can also you see also very bit of these weather reports where you put the map on top of a picture, and so those are called image based. Yep. Okay, good. So I think we'll stop here because it's time. Yes.
So where is that place we can take?
It's going to be in Blackboard.
Blackboard?
Yeah.
Okay.
Yeah, the quiz is going to appear in Blackboard week 2.
Okay.
Week 2. I'll post in slides. So write to me and I'll give. Okay.
For the group, just size of our groups. Size of our group size.